Welcome back. This is Coach Dorf again. We're in section 3.9 on related rate problem. And now we're going to do problem number 20. The problem states a baseball diamond is a square with side of 90 feet. A batter hits the ball and runs toward first base at a speed of 24 feet per second. In part A, it says, at what rate is his distance from second base decreasing when he's halfway to first base? So let's look at this here. So this is going to be part A. I'm going to draw a diagram here. So here's my baseball diamond, which is a square. And here this is first base, second base, and this is home plate where he hits the ball. And he's running along here. We're going to call this distance X. And we're looking at the distance from where he is running from home plate to first base. And we're looking at this distance to that distance to there, which is y. Since the distance from home plate to where he's at is x, and the whole thing here is 90 feet, this distance here is going to be 90 minus x. So that's what we have there. If I make it into a diagram or an image geometric shape here, what I'm really interested in is this triangle. It's the triangle that's formed by this part here. And so if I write that here, I've got a y. Here, I've got 90 minus x, and here I have 90. And in this problem, what am I given? All right, he's running toward first base at a speed of 24 feet per second. So that means xt is 24 feet per second. And what am I supposed to find? Supposed to find dy dt when x equals, he's halfway there. So halfway of 90 is 45 feet. I'm supposed to find that here. Now let's see. What I want to do next is I want to get an equation that connects. So we want to find an equation connecting the variables. So that's going to be the y, x, and given numbers. And that equation is going to be Pythagorean theorem, because that will tell me that 90 squared plus 90 minus x squared equals y squared. So I've got this. Once I've got the equation, now I take the derivative, ddt, of both sides. I want to do that. I've got ddt 90 squared plus 90 minus x squared on the left side, and I've got ddt of y squared on the right side. Taking that derivative of 90 squared is 0 because it's a constant. Derivative of 90 minus x, the whole thing squared, is by the chain rule going to be 2 times the parentheses to the first power. And inside the parentheses, I've got 90 minus x times the derivative of the inside. And the derivative of 90 minus x is minus 1. And that's going to be then a dx dt. On the right side, we've got the derivative of y squared, so it'll be 2y and a dy t. So let's see, from here I can bring over the y squared. And in fact, I'm going to write this, since I'm trying to solve for dy dt, I'll put dy dt first. Divide both sides by 2y. The 2's are going to cancel each other out. And so now I'm going to have minus 90 minus x dx dt divided by y. And now at this point, I look back and I say, well, I know what x is. X is 45, and I know dx dt, but I don't know what y is. But I can use my Pythagorean theorem to figure out what y is. So we're going to take a little break here. We're going to compute y when x is 45. All right, so using the Pythagorean theorem, I've got 90 squared plus 45 squared is going to equal y squared. And when I solve this, I'm going to end up with going to end up with y equaling 45 times the square root of 5. So I'm going to use that. So then going back here, I've got dy dt equals negative 90 minus 45, so I'm going to get 45. And then the dx dt, we were told was 24 feet per second, divided by 45 square root of 5. All right, then the 45s cancel each other out, and we get negative 24 over square root of 5. And what units am I going to have there? If I go back, my dx dt is feet per second, and my x is feet. So I've got this is in feet and this is in feet per second. But in the bottom, I also have feet. So the feet are going to cancel each other out, and I'm just going to end up with a units of feet per second. And that should make sense. Now, one thing to be careful about here. So note, this is really important. All right. Problem says, original problem says for part A, at what rate is the distance decreasing? That is why we have a negative number here. That represents decreasing. So when I write my final answer, I would say, again, I'm looking for at what rate is this distance decreasing? So the distance is decreasing at 24 over square root of 5 feet per second. If I just wrote dy dt, it is negative 24 over square root of 5. But the question asks for how's the distance decreasing. So it's decreasing by 24 over square root of 5. The negative for the dy dt represents that it is decreasing, so I don't need to write that. I shouldn't write that when I write my answer as decreasing of 24 over square root of 5 feet per second. Also, as we've said in the past, it's perfectly fine to have a negative square root to have a square root in the denominator, no problem. So that's the answer I get for this. For part B, the approach is actually exactly the same. We have our square here, the same point there. So we're going to call this, let's just call this Z. This is 90, and this is X. And so I have my triangle, 90, X, and Z. It's a right triangle. So I'm going to use Pythagorean theorem. And when I do that, I get then that 90 squared plus X squared equals Z squared. I take d dt of both sides. And in this case, I get 2x dx dt equals 2z dz dt. I want to find dz dt. So I'm going to divide both sides by 2z, and the 2's cancel out just like as before, and I get x times dx dt over z. And what does z equal? Well, just like we did before, we can compute or note that z is going to equal 45 times the square root of 5. And so when I plug those values in, I get 45 times 24 over 45 square root of 5. 45's cancel out, and I get 24 over square root of 5. And that's, again, going to be feet per second. Now, the problem asked is how fast is it increasing, because that distance is increasing. And I have a positive value for dz dt. So its distance is increasing at 24 over square root of 5 feet per second. So I don't need to worry about any negatives in this one because it's an increasing distance, unlike the previous part where it was decreasing and we had a negative. Hope that helps.